So let us begin with the problem number 2.28, and the problem is asking two thermally insulated vessels 1 and 2 are filled with air and connected by a short tube equipped with a valve. The volumes of the vessels, the pressure and temperature of the air in them are P1 V1 T1 and P2 V2 T2. Then find the air temperature and pressure which is established after the opening of the valve. So let us begin this problem by first of all drawing a diagrammatic situation of the problem. So this is how we can consider the problem. So there are the two vessels having P1 V1 T1 P2 V2 T2 connected by a valve, and this is a narrow tube. So this is before situation, and afterwards the valve is opened, and the situation is something like this, that the pressure on both sides will become equal. In case of equilibrium, the total volume will become V1 plus V2 and the final temperature will become T, and this is the situation which is after the valve is opened and equilibrium is reached. So if we begin the problem, so the first thing that we can say is the amount of gas remains constant. So we can say that the moles before opening the valve is equal to the mole of the gas which is after opening the valve. So N1 plus N2 in the two cylinder is equal to the final number of moles which the total system is going to contain. So if we apply ideal gas expression PV equals nRT, so N1 can be written as P1 V1 by RT1 plus P2 V2 by RT2, and in the final scenario it is going to be final pressure P, volume V1 plus V2 by R, T final, which we are writing as T. So this is going to be the first expression which we have. So if we remove R, which is common in both the LHS and RHS, so we get P1 V1 by T1 plus P2 V2 by T2 is equal to P V1 plus V2 by T, and this we are referring as equation number 1. Now since the vessels are thermally insulated, the problem is stating that two thermally insulated vessels. So since the vessels are totally thermally insulated and the total volume of the container is also remaining fixed, so we can say since the vessels are insulated, since the vessels are insulated, so we can say that the total change in internal energy delta U1 plus delta U2 is going to be 0. There is no change in internal energy associated with the system, and the formulation for internal energy or the change in internal energy which we are using is N CV dt or delta T. This is the formulation which we are going to use. So over here in place of N we are writing PV by RT and CV and T. So therefore the expression for the first part will become P1 V1 by RT1 CV, that is N CV, temperature difference T final minus T initial, plus P2 V2 by RT2 CV, T final minus T initial, and this is equated to 0. So over here in this case again we can say that CV and R taken common, so the expression will take the form P1 V1 by T1 T minus T1 plus P2 V2 by T2 T minus T2, and this is equated to 0. So this serves as the second equation for this particular problem. And now on solving the two equations which we have for P and V, So we get, therefore on solving we get P equals P1 V1 plus P2 V2 by P1 plus by V1 plus V2, and temperature expression turns out to be T equals T1 T2 P1 V1 plus P2 V2 plus P2 V2 T1. So this is the final answer for this particular problem which we are looking for, the final temperature and the final pressure. So on solving these two equations we reach this point. So the two important aspects which we are used in the problem is that the vessel is thermally insulated, and since it is a closed system, there is the total number of moles before and after is going to remain the same. So using these two basic aspects we have solved problem number 2.28.